Hello, everyone. Today's seminar lesson, I'm going to walk you through some examples of how to find the limit using algebra. Okay. So number 1a, I have limit as x approaches 3 of quantity x squared plus 1 squared. Right? So the first thing first, when you're doing limit analytically, the first thing first you do is you plug in the limit. That's the first thing you do. Always plug in your limit. Okay. So if I plug in 3's in to see what I see. Using limit laws, of course, if I plug in limit as x approaches 3 of quantity now, instead of x squared, it's going to be 3 squared plus 1, and we square outside. So I have 3 squared is 9, plus 1 is 10, 10 squared is 100. So the limit is 100. Okay, part B, limit as x approaches 2 of sine of pi x over 2. So again, first thing first, plug it in to see if we have the limit, right? So if I plug it in, limit as x approaches 2 of sine of pi times 2, right? Instead of x, it's going to be 2 divided by 2. We see 2 and 2 cancel, so it's just sine of pi. So what's the limit at x approaches 2 of sine of pi? Sine of pi is 0. Right, so limit as x approaches 2 of sine of pi, which is 0. Yeah, 0. And what is the limit of a constant? Well, the limit of a constant is a constant, right? Limit law, limit law. Review your limit laws if you forget, right? It's important that you review the theory before you jump into the hands-on problems. So this is equal to 0. Okay, all right. Part C, limit as x approaches 2 of x minus 2 over x squared minus 4. So again, I'm going to plug it in to see what I see. 2 minus 2, that's 0 on the top. In the bottom, I have 2 squared, which is 4 minus 4 is also 0. So I got 0 over 0. It's not a good news, right? Bad news, not a good news. So when I see this form, I have to do something before I plug it in the limit, right? So I see that the bottom is the difference of 2 squared, right? X squared minus 4. I can factor it as x minus 2, x plus 2, right? And see if we can simplify some sort. Limit as x approaches 2. I'm going to rewrite the top here, x minus 2. And the bottom, we're going to factor it at 2 binomial, which is x plus 2 and x minus 2. And as you can see, I can cancel x minus 2 on the top with the x minus 2 in the bottom. So now my limit is, as x approaches 2, is 1 over x plus 2. And now I can plug in my limit, right? If I plug in, what do I see? 1 over 2 plus 2 is 4, so 1 over 4 is a quarter. See, now we can plug it in without having the 0 over 0. Okay, 0 over 0. Part D, I have limit as x approaches 0 of square root of 3 plus x minus square root of 3 over x, right? So here in this form, I see conjugate. Now you ask me, how do I know? It's just a lot of practice and doing problems. You just kind of recognize the method over time. Okay, so I just don't know it right away. It takes a lot of practice. Okay, so don't freak out if you don't get it at first. You see eventually. Okay, so here I see conjugate. So what is the conjugate of the top? Remember the conjugate. Let me remind you about conjugate. Conjugate. So if I have a conjugate, A minus B, the conjugate of A minus B, which is we put the little bar on top of that, is A plus B. All you have to do is you change the size in the middle, right? Change the size in the middle. So the conjugate of this problem here, I'm talking about the top part, the conjugate here is the plus, right? It just replace a minus into a plus. And I'm going to multiply the whole function with a conjugate, right? So it's going to be square root of 3 plus x plus square root of 3, okay, over square root of 3 plus x plus square root of 3. So notice that I just multiply by 1, right? I did not change the expression one bit. Okay, now we're gonna multiply across. We're gonna multiply across. Let me put parenthesis here. So equal limit as x approaches 0. The bottom is, let me rewrite the bottom. The bottom is x times square root of 3 plus x plus square root of 3, right? I'm not gonna distribute yet. Maybe I'll leave it there. Maybe I can simplify it later, right? Now the top, you can FOIL it. Okay, you can FOIL it. Or if you can recognize that's the difference of 2 squared, if you can recognize a minus b, a plus b, right? Remember this conjugate. Remember what I talked about there, a minus b, and the conjugate is a plus b, right? So if you multiply these two guys together, you have a squared minus b squared, right? So you have a difference of 2 squared. So what is a and what's b? What is b here? So a is this part and b is this part, right? So here's my a, and here's my b, right? A minus b times a plus b. So a squared will be what? Square root of 3 plus x. All of that square will be just 3 plus x, right? So this is just 3 plus x. So that's my a squared. That's a squared. Minus b squared. Minus b squared is square root of 3 times square root of 3 is square root of 9, which is 3, right? 3. And as you can see, that cancel, right? So I have x on the top. Maybe I'll write it. I'll rewrite it one more time. Limit as x approaches 0 of x over x times quantity of 3 plus x plus square root of 3. And then we see that this one cancel, right? So now I have equal limit as x approaches 0 of 1 over the denominator, right? Which is now is square root of 3 plus x plus square root of 3. Let me erase this part. Okay, now I can plug it in, right? I'm plugging zeros in for x to see what happened. If I plug in 0 for x, I see 1 on the top. There's nothing to plug in at the top, so just 1 remain 1. 3 plus 0 is 3. So square root of 3 plus square root of 3 is 2 square root of 3. Right? I hope nobody's saying square root of 6. This is like x plus x is 2x. Okay. All right, so that will be our final answer. If it bother you, you can rationalize it. So we equal to square root of 3 over 6. I think these both answers are acceptable. Okay, unless your professor is kind of anal about the square root in the bottom, you can rationalize it yourself. Okay. All right, the last part, I have limit as x approaches 2 from the right, quantity of x, so absolute value of x minus 2 over x minus 2 plus 2. I hope nobody gonna just go ahead and cancel that. It's not that simple. I wish it was, but it's not, right? It's not that simple. So because of that absolute value. Now, recall that if you have absolute value of something, right? If I have absolute value of something, maybe I'll put in the bottom here. So that something inside, remember absolute value is distant from 0, right? So distant is always positive. That's why there's absolute value, right? Now, if I take away the absolute value, x could be what? X could be negative or it could be positive. Right? I don't know which is which, but here, let's see what is gonna be when I remove the absolute value in this problem. Okay, remember this problem, we have absolute value of x minus 2 on the top, right? So I want to remove the absolute value. How do I remove it? Well, I'm going to use the information, the fact that I know that the limit is approaches 2 from the right. So what's 2 from the right? Well, it could be a big number. It could be like 3, 4, 5, 600,000, right? Or it could be a smaller number, but bigger than 2. So for example, it could be 2.1. 2.1 is bigger than 0, bigger than 2, right? 2.01 is still bigger than 2, or 2.001 is still bigger than 2, right? Or 2.0001 is still bigger than 2, and you get the idea, right? No matter how close you get to 2 from the right, it's still bigger than 2, right? Not at 2, but just get close to it, very close to it. So that means the x here, the little x here, right here, let me circle the x there is bigger than 2. So when I remove the absolute value, I know that x minus 2 is going to be positive, right? Because I know that 2.1 minus 2 is still positive. 2.01 minus 2 is still positive, still positive, still positive, right? As long as you stay to the right of 2 and you subtract 2, the whole thing is still positive. Okay, let me erase that. So I know that that thing inside the absolute value is the positive value. So when I remove the absolute value, that's just x minus 2, right? So this means I'm going to rewrite my problem. Limit as x approaches 2 from the right of x minus 2 over x minus 2 plus 2. Okay, so that's how I rewrite my problem without the absolute value. Now you're going to use your logic to explain why you remove the absolute value without adding the negative. Okay. Okay. All right. Now I can cancel. Now I can cancel. Okay. So now I have limit as x approaches 2 from the right. If I cancel, what happened? It's just 1, right? 1 plus 2 is 3. So limit as x approaches 2 from the right of 3 is 3. Remember, the limit of x approaches something of a constant is equal to the constant, right? Limit law. Okay, and that's how we solve the limit u analytically. Okay, thank you for watching.